Awesome. All right. Without further ado, let's please welcome Brad Risse and Tyler Jorgensen to talk about this.
So my name is Brad, this is Tyler over here, and we're from DevObsessed. What we normally do on a day-to-day basis is we go to clients and we help them become LLM assisted, not just the development teams, but also their PMs, their POs, their QA, and they've effectively just been given the tools without any instruction, and then there's a whole mindset that goes with it, so we help facilitate that. And today we're going to be talking about Claude Code primitives, the Orcaswarm engine, which is our experiment to try to automate the entire SDLC process. And you'll see what we achieved, but also some open-ended questions and what we're continuing with that experiment. And then finally, some of the future proofing knowledge, how to become temporal aware with your memory for your AI agents. And so I'll turn it over to Tyler to start the Claude Code primitives.
All right, perfect. So anytime we typically ask somebody, hey, how much are you using AI? You typically get a response about, well, I'm, chat GPT and some things, right? And just talking to it as a chatbot, right? So how do we get from just a chatbot to turn it into a collaboration partner? Okay, so that's where we look at the primitives of Claude Code, and we're going to understand how to turn it into that collaboration partner. There we go. All right, so 6 primitives we'll cover tonight. So memory for Claude. Claude has its Claude MD file. Every time Claude starts up, it has nothing. Okay, so whatever you provide it, it only has that context. That's what we'll cover there. We've got hooks to give it more of a deterministic approach instead of probabilistic nature. We've got sub-agents that we can handle delegation for. When we look at the skills, how do we specialize the workflows? How do we keep it consistent across the teams versus everybody prompting it differently? Not only that, but MCP servers. How do we allow the agents to communicate with the rest of our infrastructure? And then how do we bundle some of this stuff into plugins that we can easily share across?
One step to the left, you're blocking them.
Oh, thank you. All right, so for the memory file, we mentioned that at the start, Claude has nothing, right? So it starts up, what does it need to know? Okay, so think of it as if you're trying to describe your application to a new hire, what kind of rules or architecture patterns am I going to tell it to follow? I can outline these in the Claude MD file. For every startup, it has that as fresh context, okay? And then as it goes through, it's also going to keep track of its own memory. So when it resolves some issues, it's going to write those down in a memory markdown. And from there, it can pull that back up later. So think of these as persistent memory that's going to load every time you open that Claude Code session. When we get to skills, we talked about how do we ensure consistent workflows across different teams, right? If one of you guys are reviewing code, maybe your command or prompt looks different than somebody else's. How do we take that and expand the capabilities of Claude to follow consistent patterns across the way? So we try to introduce these skills that Claude can use every time. So you can use them as your regular slash commands. We didn't mention slash commands as one of those 6 primitives. And the reason being is because skills kind of takes that over. The slash commands can only be triggered by user interaction, whereas the skills can be delegated to by your agents as well. Okay, and then within skills, You can't necessarily delegate to other skills within there, but what you can do is when that skill is picked up and triggered, you can fork the context over to a sub-agent that preloads a bunch of different skills. So that's a way you can kind of redirect it over to a handful of different other skills. Use cases for this, I bring up the PR review or code review, okay? If I'm going through trying to establish a certain set of standards in my code and I want other people on the team to follow that, we can introduce the skill into the LLM workflow, and now it can go through that same review process for anybody else on the team. Other ways that you interact with maybe database patterns, okay? So how do you want to structure all your queries? Okay, introduce some of those skills that, hey, here's a skill specifically for Postgres. Here's a skill specifically for SQL Server. We can do that, and then the best way for skills to be introduced is, or the best use case for skills is to inject those into the repos so then it's consistent across the teams.
Also, if anybody has any questions, please interrupt and we can expand on that topic if needed. So.
I have a question.
Yeah.
Could you explain to me a little more what you're saying about how you can create a sub-agent that loads more skills? Like, what was that two-step process about?
Yeah, so skills have a set of front matter you can include. So you can tell it what tools it has access to, kind of high-level description. You can introduce hooks as part of that. But one of the other things you can do is context, and you can fork the context to an agent. So what it does is, if Claude recognizes, hey, go ahead and use this skill, it's going to go to that, but then it's going to ship the context over to and delegate it to a sub-agent. And whatever agent you tell it to fork the context to, that could be preloaded with a set of skills. So if you define that agent separately and have certain set of skills, certain set of hooks, whatever that agent's using when it's running, by forking the context over there, you can now take advantage of kind of those tiered skill setup.
Skills aren't tools, right? Skills are more like just tasks. What is
They're not tools. Tasks are treated differently as well. So tasks, we can keep track of like a to-do task list, those things. So tasks would be treated as tools as well. But skills are more, how can you dial in your agent's behavior based on certain areas, right? So we talked about those specific technologies for database. Hey, I've got this because I don't care about how SQL is written for Postgres. I need it for SQL Server, so I'm going to sit there and enforce with a skill these specific patterns.
They're injected into the context like a tool, like that front matter. So the agent knows there's a skill name and a skill description. It's injected like a tool, like the MCP tool list. And then while it's doing something, it says, oh, I'm doing this thing that needs this skill, and then it will call that skill, but it won't load everything in that folder, only loads the skill MD. So you're not only are you saving context by not injecting the full skill into the context window, but also you only have that skill MD and it can expand further if it wants.
Could you go to the previous slide for just a moment? I couldn't read the pro tip text, so I'm using my phone to zoom in. Okay, I got it. Thank you.
Perfect.
Sorry, one more. So can you dump skills too? So if you loaded a skill and you did a thing and then you wanted to not use that anymore and do something else, can you kind of swap out skills, you know?
Oh, that's a good one.
Modify your context?
Yeah, that's interesting.
I think so too. Yeah, I don't think it dumps out. I think it adds on.
Yeah, it starts with the front matter, and then once it recognizes it needs it, it'll read the whole skill. But yeah, to then dump it after that, I don't think so. All right, we'll jump to hooks. So by nature, the LLM is probabilistic. So each time you could prompt it the same exact thing, but you're going to get different output. It may be close, but it's going to be slightly different. Okay, so how do we enforce things to guarantee that the LLM follows that every single time? We could give it some rules, but those rules are merely instructions. And the LLM is going to look at those instructions and say, maybe I should use these here, maybe I shouldn't. It's going to make that determination on its own. Whereas hooks, we can enforce those deterministic behaviors after certain tools execute. So we can tie it to specific tools. We can say post-tool use and say anytime the edit or write tool is used, go ahead and run prettier and format the code. Or, hey, after certain tools used, let's go ahead and run the linter. Make sure we're not having any linting issues or type issues, right? So we can introduce those in there to force that deterministic behavior.
What exactly do you mean by like tools? Like they're like shell commands or like specific? I guess that's my question there.
Yeah, so there's a set of tools. The ones I'm thinking of right off the top of my head, edit and write, that allows the LLM to interact with files. But based on the preset or the predefined list of tools, you can specify different types. So there's the like post-tool hook, pre-tool hook, and then you using regex pattern, you can add like the edit and the write, read, grep, different things like that. For executing bash scripts, that's more of a built-in agent that will handle that.
So I guess this is just really specific to Claude then, because I don't necessarily use Claude, I use Cursor with a lot. It has a lot of compatibility.
Cursor has hooks too.
Yeah.
Similar setup. You could do a shell command or any of that. It's very same thing.
And then with the regex expression, you can filter it down as tight as you want it. So you're able to drive that deterministic behavior on everything. Yeah, the difference in the exit codes there, it's just saying that's how you can block the LLM from proceeding. You can define a certain schema that comes back from the hook, so then the LLM knows how to act on it then. Or you can allow it to go through. They did introduce multi-agent hooks. These are tied to a preview that they're doing with agent teams. I don't know if anybody's explored that at all, but there's different hooks that you can tie to that. So, all right, MCP servers. So model context protocol. Anthropic came up with this, and the reason behind it is we need a common protocol for all LLMs to be able to interact with things, okay? We talk about your infrastructure, okay? How are you going to enable the LLM to interact with maybe your database and read real data? How are you going to allow it to interact with maybe Jira or ADO to create stories for you, track issues, pull down those issues and kick off an agentic workflow to go ahead and address that and create a pull request for you, right? Allowing different LLMs across the board to communicate to all these external tools and all of your infrastructure is what the MCPs allow, okay? The biggest thing to note of why the MCPs matter is because it's supported by all the tools such as Cursor, Copilot, any of those can utilize the MCP. Recently, they've had the introduction of MCP apps as well. So it allows the, like if you're on Claude desktop, you can sit there and pull in the app into the chat and work with the app. It has the context of the app right there visible for you. So if any of you use Excalidraw, right? They've got one where all of a sudden now you can pull it into the chat and it's going to sit there and draw a diagram right there for you. You can watch it real time, and then you can export that out to Excalidraw, to an image or whatever, okay? Another thing that was recently introduced that's still in kind of a preview state is WebMCP, okay? So Google's making it to where if you add certain attributes to your HTML tags, it serves up different tools available for the LLM to now interact with your website. So a way to think of this is if you have, say, like you go onto Amazon, okay, and you search for something, you've got a list of results. Well, for the LLM to understand that, it has to scan the page, maybe scan the DOM, figure out what matches, go through everything, or they can provide a tool for us to then quickly click on something, quickly add it to the cart, and grab by ID or grab by specific name. Now you can add that to the cart. Or when you get to the checkout, okay, it has to scan and understand what the, like what all the form options are, okay? But if you allow a tool for the LLM to interact with through the MCP, all of a sudden it'll give you a schema and everything. So it can quickly identify what are all the fields in this form based on the schema. It can provide that information to it. And now it doesn't have to sit there and go through the entire page just to determine, hey, you need first, last name, billing address, and credit card, right? So that's recently introduced. We'll see where that one goes, but that one opens up a whole lot of possibilities.
If I've got Docker CLI, Docker MCP, Playwright CLI, Playwright MCP, from a developer perspective, why would I pick the MCP over the CLI that's in a skill?
So the MCP is going to provide a list of tools that's available. And of those tools, it's going to provide you a schema. Okay, so you are able to quickly identify what you're interacting with. Whereas if you're going with the CLI, you have to sit there and figure out what the arguments are. You have to go out and scan the documentation, understand that you're passing in the correct arguments. You might have, authentication would be the same between both, but it's more of concise token usage because now you're interacting with the schema.
I have an enterprising question. Have you encountered issues with companies you work with not being comfortable with MCP? Because that's a challenge we're facing at my workplace, is the legal and security concerns and all of that. Is that something that you've dealt with?
100%. Yeah. So what we do is we actually show the developers how to build their own MCP, and oftentimes they have very specific infrastructure. For example, they have like, let's say a bunch of SQL Server sites with a bunch of databases. Like, yes, you could just go get a SQL MCP off the shelf, or you could build a custom one that works into their authentication. And oftentimes when you take to security, hey, our in-house dev team built this server, that's great. And so we'll just take an off-the-shelf one, do security scan, and then completely rewrite it and work it into their existing systems. That's the best way so far. Otherwise, take your security guys to their favorite venues. I don't know. Yeah.
And then you give your internal MCP root access to everything.
Yeah.
First and foremost, right?
Any other questions about MCPs? All right. Oh, last thing. So the big problem with MCPs is that if you add too many tools, it clouds up your context window. But recently, Anthropic and Cursor came out with, if your tool calls exceed more than 10% of your context, it automatically concatenates it and then treats those tool calls like searchable skills instead. It just has the title and the description and not the full parameter list. So add as many tools as you want, well, more than you used to, but yeah, add them up.
All right, so now we get into sub-agents and agent teams, okay? The agent teams is still in preview mode, but it's fun to mess around with if you haven't got the chance to yet, okay? We talked about built-in agents, right? Execute bash commands, it's got a plan agent, explore agent, and then general agents that handle multi-step research stuff. But if you kick off something, you'll see that it spawns a couple explore agents right off the bat, typically. And those are just to go out there and do its research so then it can collect back and determine the next steps. Custom agents, okay? So we talked about skills earlier of defining maybe that code review, defining some of those security things you would be looking for. Why we can do multiple things there is we can create a sub-agent that has access to those same skills, and now we can delegate that and have that run in the background. The other thing we can do with this is maybe I don't want to burn the tokens of using Opus 4.6 with everything, right? What if I'm just writing some simple documentation? Okay, now I can delegate that to a sub-agent and set that agent's model to Haiku. Okay, and that's going to be a lot cheaper for me and still get similar results. Okay, now I could also in turn have maybe a more defined implementation agent that I want to use Opus all the time, and then maybe everything else I'm sticking with Sonnet just to kind of find that happy medium, right? That's where we can utilize custom agents extensively. The agent teams aspect, okay, so if we are using custom agents, that handles delegation, okay? So we can delegate to this agent over here to do all this stuff, but those agents can't talk to each other, okay? They can report back to the main one, and then the main one can determine what to do next, okay? But the agent teams introduce a shared task list, okay? So now those agents that are spawned up, you effectively have an entire dev team there that your main agent is taking a list of like, hey, here's all the tasks I need. I'm gonna go ahead and give this agent this task, this agent this one. They can communicate over that shared task list, and now I've got multiple agents on a team tackling the issue, and it's going to get done quicker. They're able to resolve issues themselves versus coming back to me. So that's the nice part about it for autonomous workflows. Right now it does burn a lot more token usage, so just be aware of that. The one thing that you do lose with the agent teams or delegating to a custom agent versus just having a skill take care of it is the observability in the main chat. So you're able to then communicate back and forth with it if it's going through a skill. If you delegate to a sub-agent, it goes ahead and does its thing and kicks back the response, and then you can react on the response. But while that's going through its process, you lose the ability to sit there and communicate with that back and forth. So, plugins, okay? We talked about how can you, it makes sense to put skills into repos to be able to share those same workflows across the teams and everything. But how do we, what if we've got skills, what if we've got hooks, maybe some custom agents, maybe some MCP set up? How do we get that from team to team, and maybe all of those are kind of tied together? We can bundle those in a plugin, and then from that plugin, you can sit there and manage your plugins, disable your plugins, and go from there. Okay, so you can toggle the individual components on and off. The dependencies auto-activate from there. You can also keep these version controlled. So that's a huge improvement that allows by able to manage the versions there. With this, you're able to then scale faster with those different setups. So when you're combining the different skills, agents, hooks together, you can bundle them in a plugin, and then that's easier to ship that plugin over to another team versus, hey, here's a bunch of markdown files. Go ahead and put them in the repo how you determine they need to be.
And Nick's got a plugin, so go download it.
All right, so we talked a little bit about, hey, we've got some cursor users in here, maybe some Copilot users. MCPs are used across everything. That's the big thing with the protocol being standard across everything. What else is supported in cursor though? Okay, so your persistent memory is supported in cursor, your skills, as well as those MCP tools. So as more and more come out, we're starting to see cursor will end up like absorbing those into their ecosystem. So now you can bounce between the two and still get similar behavior. We did also mention, it's not on here, but hooks is available in cursor as well. So if you haven't messed around with skills at all, Claude has a skill builder out of the box. So you can ask it to create a certain skill for you, and then you can examine that markdown to see the content in it. But yeah, go ahead and get started with the persistent memory and additional skill, and see how much better your output's going to be compared to just trying to one-shot it. Any questions? All right, with that being said, I'll turn it over to Brad.
All right, so we're basically all becoming harness engineers. If you try to build a harness that writes all of your code, right? So it's like, okay, I wanted to review my code, I wanted to write my code, I wanted to do all these things with my code. So you add skills, you add commands, etc. And then after you've built your harness, you effectively are just running commands all the time. You're like, all right, get the issue, build the thing, test the thing, deploy the thing, and it's pretty much working the way you want. So Orcaswarm is sort of an experiment that we've been doing where can we get to 100% automation for the entire SDLC process? So yeah, we spend more time managing the AI harness than building the product. So we wanted something better. All right, so we wanted to stop running the same commands over and over. We want to manage multiple projects at the same time. That's the biggest thing. I often find myself now just watching the stream on one project and making sure it doesn't mess up, where what I really want to do is have multiple projects running simultaneously, and I'm just sort of outputting, hey, change this, change that, change that. So I think at some point in the future, we'll all be managing multiple projects simultaneously, and that's what I mean by harness engineer is we're not actually writing each individual code of the project, but we're managing the harness that actually builds it. So this project needs some special instructions or it's messing up, we mess with the harness. That way, if we do a similar project in the future, we can apply that harness to the next one. And so now we're just managing that. And then I want a single system from planning to merge. I don't want to have all of these apps and terminals open and I'm flicking through my Mac screens. I want one page where I can see everything happening at the same time. And just to note, we're not the only ones trying this. There's a bunch of options online. Many of them are open source. This is just sort of what we've tried and what we've learned through this. Okay, so this is like an architecture of how we thought Orcaswarm should be made. Now, we made this before Claude agent teams and their memory system, so we're actually going to start removing some of this, but effectively, and the most important part of this is the AI planning. So if your specs are not aligned with what you want the LLM to build, it will make so many assumptions that by the end of the project, you'll have something you didn't want. So we have a structured planning process that does the PRD generation, the tech stack selection, and then it breaks it up into what we're calling waves, effectively epics. Waves feature stories, and then it goes through all the stories, figures out which ones are dependent on the other, does a review of that, and then it will draft all these artifacts and it will then inject it into the state machine. So we wanted a state machine that was consistent. We didn't want the LLM to handle the state machine. So we have this circuit breaker where it's like, okay, it's going through these various stages of the process, and then the circuit breaker makes sure it doesn't go outside of that process. Additionally, it handles the orchestrator handles the get work tree. But I've been messing around with the state machine. Maybe we don't actually need that because Claude Code has a task list. And the task list already has depends on and blocked by inside of it, so your agent can actually do all the dependencies itself. And then to make it run forever, you say, hey, I want you to go out and get the first feature and all the stories, put all the stories in the task list, and your last task is going to be go and get the next feature and load all of those. And so in effect, you can create a recursive function within the task list to run forever. But then it gets to the orchestrator. That handles like the get work tree, merging into main. We do a first in, first out for the merging. So each agent handles its own merging procedures. Then we have a cool dashboard. We wanted a dashboard where you can manage it from one place. Originally, we built this in Electron. That was a mistake because Electron is not fun. We should have, if we wanted to do native, we should have probably went Tori. But even with Tori, I think that this logic should be separate. You shouldn't have your logic in this native application because what you really want is to separate it, and that's what we did. We have this engine, and then we just have like a very thin visualization layer. So that really helps when we're testing the outputs and we're trying it again, and it also makes it portable, so we could send it off to somebody else who wants to build off of it. So here's our tech stack, all JavaScript. So got Hano, we're using Bun because Claude likes Bun now, so we're thinking we might get a leg up there. Yeah, so that's sort of our approach on that.
Is that XState for the state machine?
What's that?
XState for the state?
We looked at XState, but there was so much overlap. XState is trying to do too much. I'm like, I just need like the state machine, not all the other stuff you're trying to add. Yeah. So 9 phases, backlog to done. Pure functional transitions with a circuit breaker, 3 retries per phase, 5 total with a 2-hour timeout. We increased those because I wanted to go the entire time. I wanted to start a project when I go to sleep, and I wanted to wake up with something. So we have AI-powered planning. This is the best part. In fact, some people are just pulling this part out for their process. But Claude Agent SDK drives a conversational planning wizard. And so what I see most people do is they say, hey, I want to do this and I want to do that. And the LLM, because it's a sycophant, will say, yeah, I'm going to do that thing. Instead, we built in the reverse prompting. So you say, hey, I want this kind of app. And it'll say, oh, let me go do some research on this particular subject first to gain context. And then it's going to ask you a bunch of questions. So it's going to say, oh, do you want to add this? Some competitors have this. And so you're going to come up with ideas that you didn't think of, and you're going to really build that spec out. So if you take nothing else from this, always do reverse prompting. Always say ask questions and don't stop until we come to a consensus. That's in Nick's plugin, right?
I stole it from you.
Yeah, okay. 7 gated phases. It drafts the artifacts. So the artifacts that are going to come out of this are the PRD, all the features, the waves, the specs, and then it's going to commit the plan, and the MCP tool is given to the agent, and it can now access all of that data. The execution engine, it's just a pub sub. It does that get work tree isolation, merges the queues, and there's a dashboard. We're going to get into the demo. So, all right, let's get into the demo.
Can I mention a couple things?
Yeah.
So, one, you said Claude was your memory. You don't have anywhere else where you record like historical information as it's processing?
Yeah, so that's one of the things we're actually trying to fix. The memory in Claude is like a post-it note, really, because it just injects it back in. So that's.
There's an idea where you do like an actual separate file that it's recording as it moves along.
Mhm.
And you can also, like, at some point the file becomes not as useful anymore, and then you can have it like compact also. They call that like REM sleep, where it's like pausing just to like, throw out copies of stuff that it's been holding onto and stuff like that.
Yeah, I saw another article today. They were talking about Git-based memory. I think it was Letta came out with that article. So I think everyone's trying to come at the memory problem. It is a problem. And I think any memory you add is going to be a percentage increase over the model itself, but which one has the biggest one? I don't know yet.
Like memory in quotes, because whether it's service or whether it's a Orca file or JavaScript, I guess it's just the practice of having a place non-deterministically
Right.
that's just collecting a bunch of inline, like as we're going along, I'm going to make a note of that.
Right.
This other agent said, hey, I prefer blue, and then this other agent said, no, nix that, and you're just like keeping that information somewhere,
Mhm.
and then later you can always like compress it and say, well, let's throw out some of this.
Right.
Because you could always go back to that, and then like Bob, for example, you can have Bob's memory. And so that way you can have Bob's memory and Sam's memory, and things like that, where if you restart it again, it would have like history, like recording sort of.
Yeah, and we'll kind of get into that one actually with the Temporal Aware RAG,
Yeah.
and as an option to this memory problem. But
And the other thing I wanted to mention about planning
mhm.
is, or going out and finding stuff on the internet that people have to be aware of, to be careful, is some tasks you have to just go out and do the research. Like for instance, what's behind that building over there? Like you have to go find out what's behind the building, because even if you search online, it can give you a map from the sky, but it may not be detailed enough. You just gotta go find it and then say, hey, I went over there and this is what I saw.
Right.
So there's those situations where you can't just search to find it.
Right.
And there's the other situation where there's a lot of stuff that's just wrong. Like, more people commonly think yada yada, but in actuality, somebody who's familiar with the topic would say, no, that's not right.
Mhm.
You're gonna see that online, but it's not necessarily right.
Right.
So I think those are two areas people need to be aware of, that they can't just say, hey, I read my mind. Yeah, I go out on the internet and just solve the problem.
Right.
So those are like two very active areas that people have to be aware of.
Yeah, I mentioned it being a sycophant, right? So it's eager to please. So it'll find that first one and say, oh, here's the solution. Even if it's debugging an error, it'll find the first spot and say, okay, here's the fix, I'm gonna put it in, and you're like, well, it's still broken. It's like, why? Well, go out there and come up with 3 possible fixes, research those, and tell me what's the best fix based on your research, and let's implement that one instead of just jumping to the first thing it finds. So it follows the same thing of, hey, it's going to find that first thing on the web. How do we steer it in the right direction?
Just so people know the terminology, in AI research circles are using the term the Galileo test to refer to convincing the language model to give you the correct answer, not the one that's the most popular.
Mhm.
It's been called the Galileo test, so I'm a little
All right, so just a small demo. I can't go through the whole planning process because it takes about 30 minutes, but I'll just sort of do some highlights and we'll start in the beginning here. Oh, will it let me? Cool, yeah. So on the left here, we've got sort of the stages of the planning process. So PRD, tech stack, waves, epics, features, stories, dependencies, and review. So we're going to go in this in sequential order, but it's going to start here where it says, welcome to Orcaswarm's Planning Assistant. Let's start what we're building, and so it's going to ask us some questions down here. So it has 2 questions. It's like, what domain or category? Web app, okay, go next. Target users, general public. I gave it 0 information. I didn't even give it the idea yet. So it's just kind of trying to gather some information. All right, so then it's going to take those answers, it's going to go to the next one. This is very similar to plan mode in Claude Code and Cursor. The difference here is we took it way further, where plan mode's like, here's 5 questions and I got it. I'm like, you don't got it. We need to do this whole thing. Like, you didn't even ask me if we're using React or Svelte. Like, what are we doing? So what is your core problem? So I'll just say, I need a Next.js. I need a recipe generator. And I'm on 4G, so it's probably why it's thinking hard.
Can I ask a question while it's going?
Yeah.
As part of your process, are you building in some way for it to think about how to validate itself so it can keep itself going without you having to intervene, or to keep itself on task, like a feedback loop?
Yeah, so the feedback loop is really in that task list, like keeping it going. And I'll go into why I think that actually might be the wrong approach.
Okay.
But yeah, so you can get it to go and keep going. You just can't like use plan mode. Plan mode explicitly says,
Sure.
yeah, you can't
But I mean,
continue.
like, it writes a bunch of code, and then it has to validate that. And probably the easiest feedback loop is like some unit tests, right,
Yeah.
to validate that. So does it
Oh.
forcibly set that?
Yeah, that's good. Yeah, so it does the unit test by itself. It's mandatory to do end-to-end testing, and it starts with test-driven development. So yeah, that's sort of built in. So you can see it started doing the PRD on the left here. It keeps the chat on the right because we're not done, but it's like I know enough to get started on the PRD and then we'll keep going. So, you know, dietary conditions, sure, user accounts. Now let's just keep it local for now. And it's a similar prompt to the one that Nick uses where it's like, continue asking questions until you're 95% sure. That doesn't mean we're done with the questions. You can continue to prompt it and ask it additional questions, but let's exhaust like all the knowledge that we're trying to put into this. All right, so here we go. So it's saying, okay, I think this is what I want your recipe generator to be. This is not a good PRD. I would keep going, but I'll be like, yeah, let's confirm and go to next. And it's like, okay, now it takes that PRD and it says, what kind of tech stack are we doing? And it's going to do the tech stack. And then it's going to ask for the waves. It's going to do the features. It's going to do stories. That's going to use sub-agents. There's a ton of stories. So it's going to spin up 10 sub-agents at a time, each one for each story. And then another agent comes in and says, okay, given 300 stories that we're going to do for this application, what are the dependencies? That one takes a long time, about 10 minutes. It has to read a significant amount of stories. At that point, you're in the review, and then you go into the app. So I'm going to switch over to just another app that's been going. So this is another to-do app I have. And as you can see, I went linear style. So we have our foundations, or these are the waves that I've completed already, kind of what's being worked on, the recent activity. I started with a Kanban, but then I realized that basically means that I'm moving them and I'm not. And like, yeah, I could see the agents moving them across the board, but let's just put them in a giant list because that's all I'm doing now is I'm watching this. So you can see these are the waves that I've already completed, and I can hover over and say, oh, spent $11 on this. It took an hour and 3 minutes, 100% completed. This is where we're paused on the polish and quantity. I can just press play, and it should start spinning up the agents to continue working on this application. If I go into an individual one that's already been completed, that gives me more information about this particular story, like the details, the acceptance criteria, the various phases that it went through. And then over here, I have sort of the agent chat. So I can see from an observability perspective, like, did this agent do what I asked it to do? I can actually look at the tool calls that it made. And I can chat with it if I want, or I can correct it mid story there. Cost shows me how much money I've spent on this particular project through the phase with all of the entries and how much that cost. And yeah, this is just a thin visualization layer over the engine as it's using Claude Agent SDK in the background. And all it's really running, other than the sort of checks that we put into place, is a bunch of commands, skills, and hooks. So we just built a harness around this. And you don't actually need Orcaswarm at all. You can just have your own harness in your .claude or .cursor folder and run the exact same thing. It's just this planning phase, I feel like, needs that visualization layer so you can really see like what your app is. If you like reading markdown files in your IDE, I commend you, but I'm kind of over it at this point. Like, I want something visual.
So I have a question. Is this required to use the API with like an access token and all that, or is it
Great question.
something that will spin up just like command or Claude You know what I mean?
Yeah, good question. So yeah, when you think of Claude Agent SDK, you think, oh no, I'm going to be spending all of this tokens on money and I'm showing you the price here. But if you have a Claude Code subscription already loaded on your computer and you don't provide an API key, it automatically uses your subscription. And you can't see it here, but in my toolbar, I made a little, like, how much percentage of my subscription do I have left? Because, you know, this can run for 4 hours. But yeah, you don't have to run the API key if you don't want to. Did I answer your question correctly?
Well, I'm not sure. So how do you connect your access? Then do you do a login or something?
Oh, so when you log into Claude Code, you like open the terminal and you log in, and it sort of saves your authentication within Claude Code. And then I'm separately running an agent that links to that Claude Code authentication. So I don't have to pay per API token. It just goes against my subscription.
Wait, so let me ask this. So from the terminal, I can type in Claude.
Yeah.
Boom, Claude comes up as some sort of loop thing where you're conversing, right?
Yeah.
Versus writing something that interacts with the API.
Right.
So, is there like the terminal command line thing that's somehow able to be run in the background, or is it?
Claude Agent SDK bundles Claude Code effectively.
Okay.
Yeah. You had a question?
Yeah, I'm just curious, like, what's the hardest kind of problem you've solved using this approach?
Not much, to be honest. Not much. What we did solve was the planning, probably.
Yeah.
I think this is a solid planning.
Good way to fix crappy customers.
Yeah. Well, no, that's a good point.
Yeah.
When we do this mob elaboration with the customer during this planning phase, and we're like, tell us what you want, and they ramble on, and then we add that in. We say, and we're like, we ask them the next question and the next one. Then we handle the tech stack afterwards. But keep talking. Like, I want the clients to keep talking, because the more they talk, the more ideas we have, and the better Claude can unpack the chaos into something workable. But yeah, out of everything in Orcaswarm, I think the best thing we've done is the planning. The orchestration is all right. It does finish an app, but not in the most token efficient way. And later on, I'll talk about why I feel like memory is probably our problem right now. But
I have a question. Do you have a workflow in this tool for adding on to existing projects, including projects that weren't originally generated with this tool?
yeah, so we started working on when you create a new plan, you can do from an existing code base. And that workflow is go through the app, create the Claude.md file if it doesn't already exist, create a docs file, and then spin up a swarm of agents with sub-agents to completely document the app as is from a current state. And then once it has that, then it can begin planning, okay, what do you want your features to be? But without that full documentation of the app ahead of time, then it has to read this file, read that file. So invest the tokens in figuring out all the files and how they work together, so that you can put a rule for your agent that says, if working on this feature, go look at the docs, read those first to prime yourself, and then continue on, rather than, I'm only going to read these files in order to execute on this particular problem.
So just out of curiosity, in theory, this process that you have, could you have it help you like create the video for a feature like movie, or design the schematics for like an architectural building?
Yeah, great question. We had a guy who took this harness and created a kid's book harness. Mm-hmm. And so it was the same thing, just he modified the harness and the planning was the same, but then he said, go to Canva and do this and put that together and then upload it to Amazon. And so, yeah, this harness it can be used for really anything.
Can you point to other harnesses, like Codex or Cursor?
So this one is very tied into Anthropic, only because I personally feel like Opus 4.6 is the best. That could change tomorrow. Facebook might come out with something, who knows? But
I think like the new Codex models are supposed to have real long
Yeah. I'm not sure.
I've been using Codex the last couple of weeks. It's been really good.
Do you 5, 6, or whatever? I don't think like 5,
I just tell it to do.
Got one more question back there.
One more question?
Oh, yeah, I was just wondering, first, are you doing any sandboxing, or is it just on like YOLO or dangerously skip permissions? And then also, are you doing the like end-to-end testing? Or is it like actually able to look at the app? Are you using Playwright or like Claude in Chrome? What have you found best for that?
I'll start with the second one about the testing. Playwright's the best for end-to-end testing, and I thought the Playwright MCP was going to be great. Then they came out with Playwright CLI, so you could be more token efficient. I started using that. But oftentimes I feel like the Chrome Web Dev Tools MCP is really good. And so I've been using that most often. For end-to-end test, I have it write all the end-to-end test. But even if the end-to-end test passed, the unit test passed, and everything's building properly, there's still some things wrong. And so the strategy I've employed, I think it's on another slide, but the strategy I've employed is that after every story, it does a spot checker sub-agent that has the Chrome Web Dev Tools as its thing. And so then it spot checks. And it runs through what the end-to-end test is supposed to do, and it spot checks. Then that one worked so well that I added a backend spot checker. So if you modify the schema or you change an API endpoint, go spot check that. Because that's what we do. Like we add something, we go spot check it. Okay, happy path is good. Now we'll write the test. And this has been really, really good for keeping it on track. And when you get to the end of a project or a feature, it's better than it was before. Before it's like, okay, now we have to do some ad hoc conversations for the next 30 minutes. Now I'm like, oh, yeah, just change this little thing and this little thing. So did that answer all your questions?
Perfect.
Oh,
And then sandboxing.
sandboxing. I avoided that one because I'm not sandboxing. I have looked into it. I wouldn't even say it's cumbersome because you could just use model, but yeah, I haven't just been YOLOing it the whole time.
Has there been any scary moments, or has it been all fine?
It's been fine so far. I don't think the prompt injectors have been prevalent, but now with OpenClaw coming out, I think they're going to step up their game. So I'm starting to become more aware. I've been looking at what can I do, put a hook basically in place that after a web search is done, run it through some guardrails to check for something, and that has to be deterministic. And if the deterministic function finds something, do I even want to have a sandboxed agent even look at that thing, because it could be prompt injected as well. So I think smarter people than me are going to solve this, but I'm actively watching.
So there's like NPM packages where people are starting to take like misspelled names and stuff, and so you could just like NPM install something that's misspelled and it's designed to take your YOLO mode and.
Yeah, so that's actually a good one. So when you start a new project, right, you can say, Claude, start this project up. It's gonna add all the folders. It's very token inefficient. It's like add folder, add package.json, add tsconfig, whatever. It's gonna keep going down the line. Instead, one of the techniques I learned from Anthropic's Agentic harness, they instructed the agent to create an init.shell script and basically just write this shell script to scaffold the entire project. So it's like create next app bun, and then it does npm install all of these things and scaffolds all the folder system. And then I added in there that before it does the npm install whatever the package is, it first goes out and checks to see if it exists. So it's like, okay, here's all the packages I want to put in my shell script for the initialization. It goes off and checks all of them, and if they're all good and they have, over, whatever, and the security's good, then it adds it into the shell script. But not perfect, but it's better than YOLOing it. Okay, so we're almost done. Agents need more guardrails than you expect. Without the phase gating, they skip the steps. So I said, hey, do backlog and then this one and this one, and it would skip them. I'm like, no, go do the spot checker, it would skip them. So by putting them into the task list will follow that sort of religiously. It'll go down the list. So the circuit breaker is essential. Whether you use one like Orcaswarm or you use that task list, it is essentially the same. And isolation is everything. If you have multiple sub-agents working on a single thing and they overlap in some areas, then it's going to break a lot of things. Instead, you put them in Git work trees, and then you do the first in, first out merge capability. This is not the final form. As I alluded to, this thing is not perfect. We're still iterating on every layer, from how agents coordinate to how they verify their output. And there are other teams and people working on these things, and I'm researching the way they do it and try to incorporate those as much as we can. So this is the interesting part of open questions. So spot checking versus TDD. We first thought, you know what, let's start with TDD because that's what we all avoided this whole time and everyone said it was the best, so the agent's doing it anyway, we'll let them do it. The problem with that is it was so slow and it was so token heavy. And then especially in the very early exploratory phase of your Greenfield app, you're going to rip stuff out and change things. So why are you doing TDD in the first place? So instead we went to the spot checking, especially for that exploratory phase of the application. The next thing we're going to add for the phases is if there's a front end involved, only do the front end completely mocked, no business logic. And that allows us to iterate over that until we get to the logic. Once we get there, then we can add the test, then we can add the business logic. This is a much better flow. Single agent versus sub agents, or the new Claude code team. So single agent with sub agents or the new Claude code agent teams. So we've tried both. They're both really cool. I assumed when agent teams came out that each team member, which is basically its own Claude instance, could also use sub agents, but they cannot. So that was a deal breaker for me. Also, it's beta, so I didn't want to rip everything out. So single agent with sub agents is the way to go. Your main orchestration agent should not really be doing anything. It should truly be an orchestrator. How much autonomy is too much? It does pretty good. It gets to the end of the project. But I'm thinking after each feature or wave, you should actually have a human in the middle loop and check to see, is it actually doing? So you can re-steer it and say, actually, these features are not good. Rip them all out and start over a new planning process. I don't think we're there with the models we have today to go to end to end, but knowing that potentially one day that model does exist, I'd like to have the engine that runs that model. Multi-project orchestration in Go. What does the interface look like? I tried to do 6 projects at one time. I wanted to see how many before my brain couldn't keep up. And I'm like, I don't even remember what the first one that I was working on was. I went back down to 3. It felt real comfortable. I could kind of do 4, but I think 3, at least for me, is that sweet spot. And I also feel like instead of one developer managing 3, it'd be really good if you just had a tag team human with you, partner, one person driving with the LLM, and then you don't get into this echo chamber with the LLM. You're actually bouncing off of ideas, and I feel like a tag team of humans on 3 to 4 projects in the future is really a superpower.
When you say you're watching 3 agents go, like are you like looking at code?
Yeah.
Are you just looking at what they built?
Both.
Okay.
All 3.
Okay.
Yeah.
So 3 feels like a lot.
3, well, if you set up Stage Manager correctly, if you have a Mac, you can like quickly work through them. Also a fun hook, you can just add like a little ding sound. So once it's done with a task, it dings and then I move over there. I added an additional thing to the ding. It also adds a notification in my Mac, and if I click that notification, it auto opens that part of my Stage Manager. So that allows me to go through multiple projects simultaneously.
So you're just constantly...
Yeah, and afterwards it's completely draining. I'm like, I don't want to code anymore.
That's awesome.
Let's just buy a farm and forget all this. Yeah. 6 was hysterical. I'm like, what am I even doing right now? So what's next? We're going to keep trying agent teams. I'm going to wait until it comes out of beta. I looked at their mailbox system where the agent members could actually communicate with each other, and they were saying dumb stuff, like it wasn't helpful at all. So I think they're working through that. Multi-project orchestration, distinct phases, and the dynamic reflection agent. This one's been really cool. Are we over time? No. The dynamic reflection agent, basically what it does is it's a hook that after your Claude code finishes, it goes and looks at the raw session data in the .claude folder of your root computer. So if you go in there, you can see all the JSON-L files of the raw session. So the reflection agent, along with some deterministic functions, will go through the session and say, how did it do? Did it have any errors? How did it use this skill? How did it use this command? And then it will give recommendations on how you should update your harness. Like, your agent used this skill incorrectly, or you should add a rule because it faced this error multiple times. So almost a self-correcting reflection agent. How are we on time?
20 minutes.
Okay, cool. So to the memory questions, I'm very interested in this Temporal Aware RAG. So from grep to knowledge graphs with graffiti. There's a bunch of other ones, but graffiti seems the easiest to set up. Okay, so without RAG, and Claude Code is proving us wrong, your LLM is navigating blind. It can grep, it can use the language server, it can read files you explicitly point to, but it has no way to discover what it doesn't know exists, and it will burn up tokens. Cursor is really cool because it has that RAG built in. It indexes all your files and then gives your agent a code search tool. So it just says, hey, where's the authentication? The RAG lists those files, boom, it knows exactly where to look. So super cool. So this is how RAG works in general. You have your code base, breaks it up into chunks, creates a vector store with a bunch of numbers in arrays, and then puts that into the LLM context or into the vector database. Then when you have a prompt, it turns your prompt into an array of numbers, and it's just basically a fancy way of searching. And whoever made RAG is probably very upset with how I just explained it, but that's effectively how it works. So RAG finds files, but code bases aren't a bag of files. They're a web of relationships, and this is a major failing of RAG. Services depend on other services. ADRs explain why code was written in a particular way, and a change in one module is a ripple in another. So if you have the graph RAG and you're editing a file and it says, what is this going to affect, or what are the parents of this, it has more informed information before it makes that change. And this is how graph RAG works, where you have ADRs and the relationship between them, and it can see what the decision context was and cross-project links. But there's one major problem, is that even with graph RAG, all the chunks and all the nodes are weighted equally. So that ADR from 6 months ago, recommending a library you've since replaced, it still shows up. And so that's the problem with graph RAG and RAG, is it has no idea temporally what goes on. That brings us to a temporal aware graph RAG. And so you can see the ADR on the bottom left, 001, is now been circumvented by ADR 002. So when it asks about something that's in that ADR, it only references that point. And I think this is kind of where it's going. You were talking about that file system. That file system has the same problem where it's not temporarily or temporal aware. You could put dates on it though, and then the agent could kind of figure it out. But I think what Graffiti has done here is pretty cool. And I've started implementing that into my agent as an MCP. The really fun thing we've been doing with this is errors. So every time you hit an error, put it in the graph RAG. And then if you don't run into that error anymore, or you find a different edge case, then put that in and link it together. And if you get rid of that library entirely that error was from, then you need to get rid of all of those errors in the RAG because we're not even using that library anymore. I'm not smart enough to really explain this. This is kind of from Graffiti, but it is open source and pluggable from Zep. They do offer a hosted version of this under the hood either use Neo4j or the FileCore DB, and you can effectively drop it into Docker, add an MCP, and you say if you want ADRs, errors, you can kind of mix and match. So if you wanted to discuss any of the topics we had today, or your company's interested in a slingshot and you want to see our mugs again, then contact Darrow or visit our site.
Yep. One question. How much is this permeated throughout your company? Do you even have junior devs anymore?
Yeah, that's a good question. The junior dev pipeline is basically collapsing in on itself. That's why I want that tag team that like brings on apprentices. I feel like we're going to go to apprenticeship at this point, where we'll have our children come into the field because we're not getting anybody coming through college. But yeah, it's kind of collapsed.
What do you mean by it's collapsed?
So if you, let's say you're 18 years old, you're about to graduate high school, you've been using ChatGPT to cheat on all of your tests for the last 2 years, and they're saying go into computer science, and you already know that it wrote all your code that passed all your tests in HTML class. Why would I can see the writing on the wall, why would I ever go into that field? And who's hiring right now? I need to learn, I need time to learn. What company is it going to invest in a junior developer who needs years of practice and needs that work that is now taken over by an LLM? I don't agree with it. I'm just saying that's how it's looked at publicly.
Sounds like we're headed towards the Idiocracy movie.
Yeah, unless we get apprentices. Yeah, 100%.
Because I always thought that like computer science, for example, was a way of like getting something to practice so you could learn like ways of thinking about stuff.
Mm-hmm.
And so like there's that skill set. Like I gotta think through things. But if you just hand it all over to the AI system and say, oh, it'll figure stuff out, well, once it starts having like problems with leaps of reasoning and stuff, then the person that always just said, I don't know, it kind of did it for me.
Yeah, I see those excuses in the meetings. They're like, tell me about this function. They're like, ask Claude. I don't know.
That's where the
question is they move into management where you don't have to code anymore.
Management's
still have to
tricky too.
reason. I mean, you hope so.
I do have a partial experience. I'm actually with the junior dev right now in the middle of all of this, and it's kind of more trying to explain to him how to use both AI and explaining what the AI did at the same time. And so then him thinking more about, okay, I have to understand what it's outputting, not just getting it done, if that makes sense.
Well, but I think there's another level too, which is how do you think about life? How do you think through problems you're going through?
Exactly,
How
yeah.
can you wonder, am I descriptive enough in solving this thing piece by piece? And then how do I know that I'm not making logical mistakes and stuff? So even if they didn't know the code, they should at least be able to test it and think about it, do like the Galileo test, those kinds of things. But if they're giving up all of this, they're just like, the AI.
Well, I mean, that's actually what I'm doing with that junior dev, that kind of mindset.
So that's the thing to train them. You kind of got to train that back into them.
yeah. So
It feels a little doomerish.
Yeah.
No, I'm just.
We'll sort it out.
Hold on 1 second. I'm going to get.
In the planning phase in Orcaswarm, are the questions consistent? Do you find that sometimes when you're trying to build out these artifacts, the questions aren't on point? Like, I've had cases where I tried to get a model to help a user do a particular task, but it doesn't ask the same questions every time. You know what I mean? So like, how do you make it kind of deterministic so that way you get a certain level of quality when you're trying to help?
Are you talking about a consumer-facing like chat interface where it's actually asking certain questions to the user, or?
Well, I guess I was just thinking like when you're trying to plan out your project.
Yeah.
And it's going through the stages, and it's like, what do you want? And you kind of say it, and then it needs to follow up with some more questions.
Mm-hmm.
Do you ever go, well, those questions were stupid?
Sometimes, if it's in a greenfield project with no context whatsoever, that's why I have it go search competitors on the web. But if you've got an existing code base, it can kind of infer like where you're going with it. I mean, some of them are kind of plain, like, all right, yeah, but generally they're pretty decent, especially when you say, before asking questions, go check out the code base, or go search the web, or go search the docs, and then come to me with the questions. That makes it a little bit more consistent, but ultimately it's a probabilistic machine. You're going to get a different question every time.
I got one more done. Cost. So have you determined kind of like an average cost?
Yeah, I was spending $1,400 a month when I was using Cursor. Then I switched to Claude Code, and I switched between two, and that's roughly $350. So I'm consistently under $500 now a month.
I have some experience in the what do we do with junior devs question. I work in Nebraska Innovation Labs. We are hiring juniors, looking for more. And I'm a mentor to those junior programmers. And the approach I've been taking, as this old guy who's been around, is I remember when there was actually a discussion about why do we stop teaching kids how to see machine code and read machine code where it goes, and everything's in assemblers, and then the high-level languages, and all the others. We're sort of losing what's really going on at the computer level. And it's just a continuation of the same process of higher levels of abstraction. So the juniors, what I'm doing with them now is I treat them as seniors. I say, don't come to me for instructions on what little project, side project you're going to do next. You decide, here's what the customer wants, here's the things that we're supposed to be doing. You decide what needs to be done next. And I'll watch you do it and just wait for me to jump in and say, okay, that's a really bad mistake.
Mm-hmm.
I'll let them make the small ones and see if they can correct it. But the juniors are now seniors, and the seniors are now management. It's just moving to higher levels of abstraction, and ambitions are going to be getting higher. If you have a car that opens the door for you, it slides out the seat, you can sit down, and then the car will move you in, and then it drives you where you want to go, exactly where you want to go while you're doing other things. Once you have that, nobody really wants to go back.
Right.
Once I have a phone that isn't just a stupid little smooth rectangle with no tactile feedback whatsoever, and I have an interface that I wish I had, people aren't going to want to go back. So our ambitions will keep getting higher. So that's the solution I have for the juniors. Also, I teach them the basics that don't change. Things like the first 11 minutes of the 60 lectures, which I recommend to everybody. It says astronomy is not telescope science, even though telescopes are what they do all the time. Computer science is not about computers at all. It's about formalizing our intuitions about process. And those ideas about how to information and process have not really changed. I tell them things like there is only one way to solve any problem. Every single problem always has one basic technique. You break it down into smaller problems. All other techniques are just a variation of that same thing. And so get really good at breaking things down into smaller problems. Mm-hmm. And I also coach them in the life, just the sort of the psychology and life ones about it. Not panicking about failure, get some sleep. Know that in some cases, I call them coffee problems. You're memorizing a lot. You want to drink coffee, you want to make sure that you're getting to sleep at night despite the coffee. In other cases, they are beer problems. Balmer curve is real. Well, it calms you down. It's a depressant. So there's other times where you're thinking deep. The coffee problem tends to be one where somebody somewhere on the planet knows the solution already. A beer problem is one where nobody can possibly know the solution except you because it's your system and you're deep into it. So the deep thinking tends to be one where you're not drinking coffee, you're drinking beer, and you're relaxing, you're breathing deep, you're doing other things mentally. Handling all those psychological aspects of problem solving hasn't changed at all. And so I emphasize that when I'm talking to the juniors. So I think it's a bright future. I want more kids in computer science because computers are going to be more important than ever. But we aren't going to teach them coding and JavaScript and things like that.
Right. No, I don't disagree with that point. I'm just saying that from that high school, like you're teaching the junior developers all the right things, but how many are we going to have in the future? I think that pipeline is collapsing.
I think if you take that AI native young person and they're ambitious and hardworking, just like every generation has a subset of really ambitious, really hardworking people, their productivity is going to blow us away because there's a whole set of problems we worry about they won't even care about.
Right.
Productivity is going to be off the charts.
Yeah. To add to that, I was listening to a podcast with the chief philosopher at Anthropic, and he works on the soul of Claude. what's her title? Yeah. She was talking about how if you went back 100 years, you went back in the time machine and talked to farmers, where 95% of the population was farmers, and you said, hey, in 100 years, 5% of you are going to be farmers, and the rest of you are going to have jobs that you can't even possibly comprehend, like skyscraper engineers, computer scientists, and they're just going to look at you like we're in that transition. Where it's not going to be 100 years; it's going to be 5 years. And code is becoming this artifact that no one is going to care about. You can see it today with like Claude, for example. The people who work on Claude code do not read the code that Claude code puts out. You can kind of tell because Claude code's broken every other day. But we're in this transition period where we have to let go of the notion of code being this sacred thing that we have to review every single
Reviewing
line.
code is like a huge problem now.
It's like-
Reviewing code is just a huge problem now.
Yeah.
You get so much code.
It's always been a huge problem, and you've always
But-
understood
well,
why
right.
you're PR. Don't lie to me.
Just being a tech lead or whatever, everyone's becoming a tech lead or whatever,
Yeah.
you're having to review, but just the quantity of it is
Yeah.
almost overwhelming, right?
But this is also like, it's forcing the truth upon us that everything is not sacred, it's not important. We're factory workers, we're blue collar workers pushing widgets across a conveyor belt, and we move on.
But to add to your point, we looked at the stats across a team that included more than just developers, and the project managers were using more tokens than all of the developers.
Yeah.
The juniors were using more developers than the seniors, and the project managers who knew nothing about code were using more than everyone else because they're just delegating. They're like, oh, this thing can do the thing, I don't care how it does it, and it's wow, wow, wow. So that instinct is right, yeah.
How about that? Are they getting more out of using those tokens? Because going back to the junior dev I'm working with, he actually used up all his tokens before me, but he had actual less code output than I did though. And I was using it the same amount of time, I guess you could say. So
Right.
You have
is that different though?
you have the domain knowledge, so you're able to prompt it better to produce better output.
Yeah.
So that domain knowledge is going to become more valuable. And to the review point, it's when you coded it, you had a mind map of what you coded. But without the mind map, you're lost in a review and you can't explain it. So how do you have the LLM turn around and produce a mind map for you? It can give you learning insights along the way for those junior devs to help them build up that domain knowledge going through.